All right, so this lesson is going to be in this book. So if you don't have your In Success small book, then that's what you need to be having before you right now. And then after this lesson, it'll be several lessons before we get into this small book again. But our next lesson in our big book is 1.2, and that deals with prime factorization. Well, if you haven't reviewed what primes are, prime factorization becomes a little bit more difficult. So in this video, we're going to be talking about our primes and composites for the In Success book. So primes and composites, basically that most numbers, not all numbers, but almost all numbers will go into one of two groups. We're talking about factors, and factors are any number that will go into, remember we talked about division in the previous lesson, will go into that number evenly. So if I look at the idea of 6, well, I know that 1 will go into 6 evenly. I know 6 will go into 6 evenly. But 2 will also, and 3 will. So those are all factors of 6. And it's more than 2 factors, so it's going to be a composite number. If I talk about 3, well, there's only 2 numbers that go into 3 evenly. That's 1 and 3. And if it's 1 and 3, and 1 and that number itself, then that's a prime number. So the book gives you a way of figuring out how to do that. So I would like you to make sure that you follow along as we go through the lesson, as we talked yesterday. And as you're following along, that means you're actually listening to what I'm saying and filling it out. So you have your pencil in hand and you're ready to go. So this talks about just the definitions of the two. A prime number is a whole number greater than 1 that has exactly 2 factors, 1 in itself. So it's very specific on primes. It has to be greater than 1, because if it has 2 factors and we talk about just 1, well, 1 only has 1 factor. So 1 is not prime nor composite. It's basically a neutral number out by itself. A composite number is a whole number greater than 1 and has more than 2 factors. So as we talk about factors, once again, we talk about the numbers that go into them. Now, some students prefer to list factors, like in this example for 12, in order as they think of them. I try to make it a little bit more systematic so that you know you have all of the factors as you're going through. Especially when they give you how many there are, it's easy to make sure that you have all of them included. So the way I do factors is I always write down the 1, and then at the end of the list, I always write down the number we're talking about, because those always have to be included. So 1 is the smallest one that we're ever going to have, and the number itself is going to be the largest one. So make sure you're following along, you're listening, you're paying attention, your brain is engaged in what we're talking about, and that you're writing these down as we go through them. So my first one will be 1 that I'm going to list. And then I know the number that goes into it with 1 is 12 itself, because 1 times 12 gives me my 12. From the 1 then, starting from the beginning of the list, I go through my counting numbers. And if the counting number that I mentioned doesn't go into it, I just simply skip it. So 1 counting would be 2. It's an even number, so I know 2 will go into it, but how many times? Well, 2 times what gives me my 12? 2 times 6. So I'm going to put 6 at the other end. My next counting number is 3, and I know 3 times 4 gives me 12, so 4 is going to be in my list. Now notice as I'm doing these then, the closer I get to the center, I'm going to possibly get to consecutive numbers, one that comes after another, and 3 does come before 4. So I know I've included all of my factors. Now I could always check, and my next counting number would be 5. 5 does not go into 12, but 6 is my next counting number, and it's already up there. So I do have them all covered. When I look at 13 then, if I did the same thing, my first one would be 1, my second one would be 13, and as I went through all of my counting numbers, 2, 3, 4, 5, 6, 7, all the way up to 12, none of those go into 13 evenly. So a composite number has more than 2 numbers that go into it, or more than 2 factors, and a prime number only has 2 factors. Now, we're going to spend some time, and this is going to take a little bit, I would advise you to get a pencil and a highlighter. And if you don't have your own highlighters, then my highlighters are over here on this in this carrying case in one of those cups. So in your book, you have this information here. You have the chart from 1 to 100. Now understand that when we're finished, we're going to have a list of just primes from 1 to 100. However, what we're not going to have is a list of all primes. Numbers are infinite, and go on forever. So therefore primes would go on forever. And we can never have a complete list of prime numbers. But we're going to follow these steps and go through one after another. And the first thing it tells us to do, step 1, cross out 1 since it is not a prime number. So when we cross them out, we're going to use X's each time. Now on mine, and hopefully you can see it, I think you can on the video, I use colors for each step that we go through. You don't have to do that. Put an X on the 1, it is not prime. And then it says for step 2, circle the 2 since it is prime. So when I put a circle around them, I'm just going to circle the number itself. But there's a second step to that. It says to cross out all other multiples of 2. Well, multiples of 2 are what type of number? Hopefully you thought, well, they're going to be even numbers. So I look at my list, and from 2 going all the way down to 100, if it's an even number beyond 2, I got to cross it out because I know 2 goes into it evenly. So that one's going to take me a few minutes, but I'm going to cross them out. 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. Notice I'm filling in the columns. So anywhere that the numbers end with a 2, I can fill in that entire column. Anywhere that the numbers end with a 4, I can fill in that column. Anywhere the numbers end with a 6, an 8, or a 0, I can fill in those columns. So all of those will be crossed out. All right? So take the time to do that. And then, watching the video, if you're not finished before I move on, then remember you can always pause the video. If you weren't paying attention, you lost focus, then that's where you can always rewind the video. So those should be crossed out before we move on to the next step. Step 3 then says, circle the next number that is not crossed out. Well, my next number not crossed out is the next counting number, which is a 3, so I'm going to circle it. Why? Because I know that the 2 doesn't go into it, and therefore that has to be a prime number. Now you're going to cross out all of the multiples of that number. So I have to multiply by 3s all the way through, or I can go every third one. Now as I do it from the 3, my next third one, 1, 2, 3, is a 6. And it's already crossed out because it's even. And then from the 6, I go 1, 2, 3, and I have a 9. Okay, so I have to cross that one out because I know 3 will go into it. So once again, we're going to use X's to cross out and eliminate. So going every third one then, what we have is from the 9, then I went 10, 11, 12, it's already crossed out because it's even. 13, 14, 15, I cross it out. 16, 17, 18, it's already crossed out. 19, 20, 21, I cross it out. Then I go over to the 24, it's already crossed out. So now 27, I cross it out. The next 3 would take me to 30. It's already crossed out because it's even. So I have to go to 33 and cross it out. 36 is done. So I have to go to 39. Cross it out. 42 is done. So I have to go to 45 and cross it out. 48 is done. So I have to go to 51 and cross it out. From 51, going over 3, 54, it's done. So I'm going to 57 and I cross it out. From 57 over 3 takes me to 60. It's already done. So I'm going to go to 63 and cross it out. 66 is done, cross out 69. 72 is done, cross out 75. 78 is done, cross out 81. 84 is done, cross out 87. 90 is done, cross out 93. 96 is done, cross out 99. So once again, if you don't have all of those crossed out, then pause the video, fill them in with your cross or your X's, and then we go on to the next one. So my next one tells me to repeat step 3 until every number is either circled or crossed out. All right, so repeat 3. 3 said to circle the next number that is not crossed out and cross out all of its multiples. Well, my next number that is not crossed out is the 5. All right, so if I circle it, because I know it has to be prime, then I'm going to cross out anything that is a multiple of 5. When I do that, well, then I have to go to 10, which is done. 15 is done. 20 is done, but 25 is not. So my next one that I'm going to cross out is the 25. Now when I do that, crossing each of those out, in this case I use black, I really just have to fill in the rest of this column. All of these are done because they're even. And I know that 5 will go into any number that ends with a 5 or a 0, and those are the only numbers that it will go into. So I'm just filling in the rest of this column. Does that mean I'm finished? No, it says to repeat step 3 until I am finished. So everything has to be circled or everything has to be crossed out. So now I'm going to 7. 7 is my next counting number. I know it has to be prime, so I have to cross out all multiples of 7. Well, let's see, 7, that's 14, 21, 35. And as I go through, I'm going to see I only have 2 numbers that are multiples of 7 that I can cross out. 77, oh, excuse me, I said 2, there's 3. Backing up, 49 wasn't crossed out, so I have to cross out 49. 77 wasn't crossed out, but 7 will go into it, so I have to cross it out. And then 91, 7 will go into it, so I have to cross it out. Repeating step 3, now I have to look at 11s. Now my multiples of 11, I know 11 has to be prime, but my multiples look like what type of numbers? They're those doubles, right? 22, 33, 44, 55. Now notice on our chart when it's lined up correctly, that takes us to this diagonal going all the way down. This is where our doubles are, and every one of those is already crossed out, so I don't have to worry about it. My next counting number, it has to be prime because nothing smaller would go into it. 13, and we already talked about how 13 is a prime number, so I'm going to cross out all the multiples of 13. Well, there's none, is there? So then I go to 17. And I circle it, it has to be prime, and I cross out all the multiples of 17. I don't have any. So I go to 19, I circle it. I cross out the multiples of 19. I don't have any. So what you end up seeing is as you build through this, then everything that's left is actually a prime number. Each of these numbers that are left, what you're left with is a number that only has 2 factors. 1 and itself. There's several there. Now, I could be mean and say I expect you to learn and memorize all of the prime numbers from 1 to 100. But I really don't see a purpose of that. So I have a paper for you that shows you all of these. Now, if you had to look at this, even for me, that looks a little confusing. Okay? Trying to figure out where the circles are, and I have a whole bunch of X's. So what I've done then is I just covered up all of the X's with black. That helps us see specifically just our primes and lets our eyes focus easier on what our prime numbers are from 1 to 100. So on one side of our paper, I have given you this chart so you can put it in your math folder and get it out any time that you have a question that references prime numbers. That includes homework as well as tests, other than the NWEA that we take and the I Learn. Right? So you have to eventually think about these numbers, and I give you only 5 that I really expect you to have in your head because we say it so many times that you'll remember. So if you have a trouble remembering all of those primes, which I would have a trouble remembering all of those primes, there is another way that we can do those. Okay? So on the other side of your charts, then I've given you what is called the divisibility rules. Now, divisibility just means what can be divided by. Okay? And now each of these, there is a rule that you can learn that will help you know if a number will go into it or not. We've already talked about a couple of them. For 2, it's an even number. So I know 2 is prime. However, 2 will go into any number. So that would be considered a factor of it. It's divisible by 2. The rule for 5, well, if it ends with a 0 or if it ends with a 5, I know 5 will go into it. So it's divisible by 5, or 5 would be a factor of it. The idea of that 0 or 5, well, the 0, that's the 10 also, right? So if a number ends with 0, I know 10 will go into that number evenly. The others, some of these we don't use on a regular basis, but you'll start using them in junior high and even your freshman math class. But 3s. So the rules of 3s is one that I will reference quite often in the 9s, which they're very similar one to another. The divisibility rule says if the sum of the digits is divisible by 3. So let's say I had the number 123, and I look at it and I'm like, I really don't know if 3 will go into it evenly. And when it says the num of those numbers, so I have to look at it the 1, the 2, and the 3 if the number is 123, and I add 1 plus 2 plus 3. 1 plus 2 is 3 plus 3 is 6. That's the sum. 3 will go into 6 evenly, so I know 3 is a factor of 123. 9 works the same way. If I have 98, and I'm not really sure if 90 or 9 will go into 98, I add the 2 numbers together and see if 9 will go into it. Well, 9 plus 8 is 17, and 9 doesn't go into 17 evenly. So I know 9 is not a factor. So these rules will help us throughout the year as we talk about reducing and what numbers will go into other numbers. But for an example that we can use, 111. What numbers will go into 111? Or is it a prime number? Well, 2 will not go into it because it's not even. 5, it doesn't end with 0 or 5, so that doesn't work. 10, that definitely doesn't work because it doesn't end with a 0. So if I look at 3, where I have to do more math, and I add 1 plus 1 plus 1, I get 3. And 3 does go into 3 evenly, so I know if I divided that out, 3 would go into 111 evenly. All right, so going on to our assignment. Now, this is one of those assignments that's pretty easy. There's really not a lot of work to show on most of it. So we just have to take our time and make sure that we do as it asks to do, which is to tell whether the number is a prime or a composite number. So number 1, if I would get my chart out and look at it, all I have to do is say or ask, is 11 on my chart? And it certainly is. So I know 11 is a prime number. Okay, so if I write down the word prime, then I would have that one correct. All these other numbers are larger than 100, so that really doesn't do us a lot of good for the rest of these. So that means if I think about my divisibility rules, then I might have a better chance and it might be easier. So if I look at 417, I got a little bit ahead of me, 417, and I start going through my divisibility rules that I just mentioned. You have the chart so you can look at it, but on 2s, it has to be even. There's a 7 in the 1's place, so I know it's not an even number. It doesn't end with a 5 or a 0, so that eliminates 5 and 10. So if I look at 3s, the rule is to add each of the digits together. So I have 4 plus 1 plus 7. That gives me 12. 3 does go into 12 evenly, so I know that that is not prime, is it? If 3 will go into it. So that is a composite number. So the ones that we're really going to focus on are 2, 3, 4, 5, the 9, and the 10 as we go through these. Now, if you want to take your highlighter and highlight these, so those are the ones that you really begin to use often and remember, then that would be a good idea. Number 3, 282. Is it an even number? That's the rules for 2. It is, so automatically that is a composite number because there's a 2 in the ones place. 605. It's not even, but if I look at the 5s, it has to end with 0 or 5 in the ones place, which it does, so I know 5 will go into it. So it's composite. So I'm not asking you to do the divisibility and show what it's going to equal if I take it into it. You just have to identify, is it prime or composite? Should be pretty easy, I'm hoping. Number 5 says tell whether the number is prime or composite. So exactly what we did up here. Is 234, my first rule, is it an even number? Well, there's a 4 in the ones place, so I know it has to be composite. 1006, there's a 6 in the ones place. It's even, so I know it's composite. 109, well, that's not even, is it? So I don't know. My next 5s, well, it doesn't end with 0 or 5. So that eliminates the 10 also. Well, let's try the 3. 1 plus 9 is 10. 3 doesn't go into it evenly. The rule for 9 is add them together and see if 9 goes into it. Well, that was 10, and 9 doesn't go into it evenly. So what we find out, if we would have continued our from 1 to 100 prime chart, 109 is actually a prime number. I go to 129. It's not even, doesn't end with 2, 4, 6, 8, or a 0. 5 will not go into it because it doesn't end with a 5 or a 0. So I check my 3s and I add 1 plus 2 plus 9. I get 12. We said earlier 3 will go into 12 evenly. So I know number 8 is a composite number. All right, so we're going to skip a couple of problems and we're going to go to these questions then. Now these are going to be, short answer, sentence answers. So make sure that you're being precise and concise when you are writing them down. The number 1 is not prime. Is this true or false? And if it's false, I have to explain why it is. Okay? Or give an example, excuse me. You have to give an example and support your answer. It is not prime. That's a true answer. How can I support my answer with that? Well, it only has one factor, and primes, should be prime numbers, have to have 2. So 1, the only factor is 1 itself. So it can't be prime because by definition, a prime number must have 2 factors to it. Number 14. Now, if you don't have that written down, pause the video, write it down, and then we'll go on to it. A composite number cannot have 3 factors. Composite cannot have, well, that's false, isn't it? Because if a prime number has to have 2, then I know composites have to have more than 2, or at least 3. So they have to have 3 or more in order to be composite. Number 15, only odd numbers are prime numbers. So if you looked at that prime chart real quick, the very first prime is not an odd number, is it? So that has to be a false statement. Okay? 2 is an even number. All other prime numbers are odd. And then 16, every multiple of 11 is a composite number. Well, that's a true statement also. How do I know it's true? Because if it is a multiple of 11, then 11, would be a factor, and therefore it has to be a composite number. So if you don't have those written down, make sure that you get them written down. So pause the video, and then you can continue on. Now, we skipped 9 through 12, just in case you're struggling, and we can go through the charts together. Meet with me in the assembly area, and we can talk them over. If not, then in your small In Success book, on page 5, you have questions 2 through 14. And then on page 6, which is the back side, you have 1 through 6. So the 1 through 6, it'll be some of today's, but it will also review the previous lesson that we did yesterday. So as you're going through it, if you have any questions, then please come and ask. If not, you may begin your assignment.